because, you know, every subject likes to have its own terminology. Okay, so here we go. Ooh, apparently I'm making a video. All right, so since it's already doing it. So first we're going to look at natural numbers. Natural numbers are any positive whole number. So, example here, 0, 1, 2, 3, 4, 5, 25, 82, 1,374. Okay, any positive whole number is a natural number. We will represent natural numbers using this symbol. Okay, so natural numbers are...
Is it like an N with like two stems?
Yeah, you kind of use two stems on the beginning of the N. Okay, so N for natural. All right, so an integer, you've seen this before, right? An integer is any positive or negative whole number. So it also has to be a whole number. So here I show these squiggle brackets that you see here. These here, when we see brackets, anything listed like this, it is a list. It's a list to represent a set of numbers. Okay, so when they're separated by commas, it means that you're like every single one of those numbers, but individually. Okay, so it's just a set of numbers, and so that is our list. Integers are represented with what? They are represented with a Z. With that, you know, double body. A double-bodied Z. Okay, so I only show, notice I put ... -3, -2, -1, 0, 1, 2, 3, ... The ... before represents any negative whole number smaller than -3, and the ... after 3 represents any positive whole number after 3. Rational numbers. What is a rational number? So a rational number, first of all, is represented with a Q. Okay? So it is represented with that Q that you see at the top left that I just drew. A rational number is any number that can be represented as a fraction. So generally a finite decimal, or an infinite repeating or periodic decimal. So any of the numbers I wrote above, so like 2/3 is a fraction, so it would be considered a rational number. If you did that in your calculator, you get 0.666666666 repeating. So as soon as you have a repeating decimal that already qualifies as a rational number. 0.5 is a finite decimal, and it can be represented as a fraction. What fraction would that be? 1/2, okay, would be the simplified. -4/5 is also a rational number. So a rational number can be negative. Then we have 9.999. If I represented that as a fraction, I would get 9999 over 10,000, right? 1/8. Down at the bottom, I show some other periodic repeating. So 0.81818181. 0.333333, 0.1234, 1234, 1234. I will be showing you later how to turn those into fractions. Okay? Yes, Carmine.
What's the fraction for 9.99?
That one, yeah, well, it would be the easiest way to write that would be 9999 over 10,000, right? Just like if I, like 0.9 would be 9/10. Mm-hmm. All right, so what an irrational number will also be a Q, but with a little prime at the top. Okay, so an irrational is the Q, but with the prime. So an irrational number is anyone that can't be written as a fraction. So the square root of 3, the cubed root of 2, If I asked for instead, let's change that, and I said, oh, the cubed root of 8. What's the cubed root of 8?
2.
It's 2, right? The cubed root of 8 would be 2. So this is a rational number. It does not fall as the irrational. So this is a rational number. But if you take the cubed root of 2, the cubed root of 2 would be 1.2592105 and might continue on forever. So that would be an irrational number. So 9.12324333654, right? That has a non-repeating decimal. So we're looking at infinite non-repeating decimals. Okay, and so most roots, unless they give a perfect integer answer, will be irrational numbers. Okay? Then we have, the set of all real numbers. Don't worry, I'll go back. The set of all real numbers. Here it's represented. It is the IR. Okay, so it's kind of like connected. It's actually not IR. It's hard to just draw that symbol. It's like that double-breasted, double-barred. Hang on, I'm gonna use a different color here so it's easier to see on this blue. So it would be an R like this, just like usually we'll draw our Q's with that line, right? The Z will have the double line. N should kind of be connected there, right? So double-bodied N. Okay, double-bodied Z.
Miss, what's the Q?
Okay, Q is rational or irrational, right? And then the Q prime is your irrational. Okay, all real numbers, these are your all real numbers. So the set of all real numbers is basically any number that exists. Positive, negative, decimal, whole number, infinite decimal, repeating decimal, doesn't matter. Right? It's just our rational numbers are separate from the irrational numbers, as you can see by the Venn diagram. But within our rational numbers, we have integers. Within integers, we have our natural numbers. Because any positive whole number is what? It is an integer, but it's also a natural number. Okay? And then our rational numbers can be any integers or any decimal values. So hang on one second. You do have a bit of work to do.